integration of inverse trig functions is exactly the opposite of what we did with the derivatives of trig functions in the previous lesson. It's going to be the same thing, only in reverse. Integrations is basically anti-derivatives, and so we're just basically doing whatever we did last time. So these are the three main formulas that we will be working with in this. The key to solving these problems is trying to find a way to make the pattern fit. You may have to multiply something or add or subtract something to get them to be exactly the same. And we'll show examples of that. And but it's just an exercise in mathematical manipulation that you guys have become so much better adept at. So for number one, this is the integral of 5 over 9x squared du. Now, if we replace u with x and du with 1, and one thing that we have to be able to identify is the value a. A is generally a number, although I guess technically it doesn't have to be, but we generally use a number for that, and the variable part is the u squared. So sometimes the orders have to be switched around, and again, we'll talk about that. But in this particular case, this fits the pattern of the sign one, the number one of the three options. So we do want 1 on top, so that means since 5 is 5 times 1, we're going to pull the 5 out to fit that pattern. So it's going to be 5 times the integral of 1 over, and it's 9 minus x squared, and I've rewritten that in the form of 3 squared minus x squared, where a is 3 and u is x. And to fit that pattern then, since a is 3 and u is x, this is the arcsine of x over 3 plus c for that part of it, and multiplied by 5 on the outside, and there you have your answer for number 1. Number 5, the pattern here is going to be involving the secant part of this thing. If we take a look at that, the secant part looks like you have du over u times the square root of u squared minus a squared. So that's why we're choosing that, because we are getting a non-radical multiplying a radical here. That kind of lets us know that it's going to be that third one, the secant one. So because 4x squared is 2x quantity squared, we're going to make u 2x, and the derivative of 2x is 2. So x then manipulate that, make x equals u over 2, and a is 1. So when we plug this stuff in here, we want to end up with the pattern being shown here, which is 1 over a, or du over a, but it ends up with 1 over a. So we simply take the du for that, which we said was 2x, I'm sorry, 2 rather. So this becomes 2 over 2x, because that's what your u value is right there. There's your u value, that's your 2x, and then u squared minus a squared is 2x. This quantity right here goes right there. We bring the 2 over 2 out over here, that leaves us 1 over x times this quantity right here. And that means then that cancels out to be 1. And so 1 over 1 times the arcsine of the absolute value 2x, which is your u value over your a value 1 plus c. And then of course you have to remove any extraneous, I put the same thing twice. I meant to put just plain absolute value 2x right there. But it's implied as 1 being the a that's in the denominator of that, which is what I showed here. But then I got rid of the ones in front and underneath in the denominator to give us that. But again, find the pattern that fits it. All right, for number 9 now, we're given this problem right here. We're asked to find that. This fits the pattern 5, 17, 1, which is this right here. So we need the value of u, which is x plus 1. du then is just 1 because of the x. And then a is 1 because of this right here. So this just falls right into the pattern because du is 1. And so that's not even involved in this. That's nice. Except the fact that it confirms what we have there. But this is equal to the arc sine of u over a. Well, we said u is x plus 1. A we said is 1. And plus c. So it's x plus 1 over 1, which is x plus 1. So the arc sine of x plus 1 plus c is our answer for number 9. Number 13 fits the pattern number 2. And for this right here, when we take a look at e to the 4x, we have to remember that that is the same as e to the 2x squared, because you're going to multiply these two exponents. So when you're trying to find your a value and your u value, your a value is the 2, the u value is e to the 2x, and the derivative of that is 2e to the 2x times 2x. And so when we plug in these values for u, this is what we get. We have to move, since we want we have the 2 in front, and we are going to want to make sure that that happens. Then the e to the 2x has to become 2e to the 2x, so we need to put a half in there to get that and bring that out in front to allow for this to occur here. And so that puts 2 squared plus e to the 2x squared up there. So we got our half du there. And that means then that this fulfills the definition for arc tangent of a over, or u over a. And so this becomes 1/2 times 1/2 arc e to the 2x over 2 plus c. And this will give us then 1/4 arc tangent e to the 2x over 2 plus c. So it's just all a matter of following the patterns and then manipulate the numerator such that we can get the value you're looking for. And it all kind of falls in place for that. Number 17, we have here, this is going to become 2 problems because you have a division here that you're integrating. So you integrate x over x squared plus 1 dx minus 3 over x squared plus 1 dx. This is just a regular pattern here of non-trigonometric functions. This, however, is a pattern for the trigonometric function. The second one that involves the tangent follows that pattern of du over a squared plus u squared. That's for the arc tangent. This right here is just is going to be a function problem of normal values here. We're going to give u the x squared plus 1, and 2 dx is du, or dx is equal to 1/2 du. And so this becomes then 1/2 du over u. To get the d over u to work, we pull the 1/2 out. And that's going to give us then, when you take the integration of that, that gives you the natural log of u. And the 1/2 of that, because of that 1/2 that got pulled out. Over here, we have to pull the 3 out because we want a to be x because of the x squared, u to be x because of the x squared, a to be 1 because of the 1 squared there technically, and the du is 1. And so du is 1 goes on top. It was 3, so we have to think of this as 3 times 1. And so we pull the 3 out and leave the 1 inside. You got the x squared plus 1 over there, which can be written as 1 squared plus x squared, because it's the same thing. A is 1, u is x, as we talked about. And so that becomes, this can be then, once you integrate it, this gives you the -3 on the outside because you're subtracting because of the division you had at the top. Arctangent of x, because that's your value of u, plus c. So this entire answer, again, a two-stage or two-part problem being brought together into one, and this is the answer you should end up with. Your practice problems are found on page 385, 2, 6, 10, 14, and 18. Have fun.